All right, so we're going to look at 10-3. We're skipping 10-2, which is tessellations. We'll do tessellations fourth quarter. We'll do something fun. All right, so today we're going to look at area of parallelograms. Oh, 10-3. Thank you. So 10-3 area of parallelograms. Most area formulas can be derived from the area of a rectangle. So although you won't have to memorize most formulas because they're on your Ames reference sheet, they're easy to know if you can derive them quickly. So for instance, if we look at the parallelogram, and then within this parallelogram, this would be the height of the parallelogram. So think of the parallelogram as really basically a rectangle that's been pushed over. Couldn't this have been the rectangle area of that parallelogram in pink? And all I did was take this and push it to the right. So what's the area formula if this is my width and this is my base? I guess I'll call it my length. If this is my width and this is my length of my rectangle, isn't the area of a rectangle length times width? So wouldn't the parallelogram be exactly the same? But on a parallelogram, we call this distance the base from here to here, and then this is the height. So your area formula for your parallelogram is typically base times height. Oftentimes they're going to give you this diagonal measurement here and try to have you use that as the height of the parallelogram, but your height always has to be perpendicular to the base. And if you measure this distance from here to here and measure this distance from here to here, are they the same or different? They're different. So these cannot be used interchangeably. So do be careful. They're going to try to throw some extra information on you to see if you'll try to use this number here as the height. Now we might have to use our knowledge of special right triangles or trigonometry in order to find the height of a parallelogram. So be aware of that. So also know that, so this is your parallelogram. So your area formula for a rectangle is equal to length times width, or also base times height. That's why oftentimes you hear people calling them the same. All right, so example 1. Find the area of parallelogram STAR. Sometimes you'll be given a picture. Oftentimes you won't be given a picture. And if you're not given a picture, it is your job to draw a picture of what they are describing to you. And I think those will be the hardest problems for you to do because you have to draw your own picture. Remember that polygons are named, if it's named STAR, those letters have to go in that order. In other words, you put the S wherever you want to, it doesn't matter. But if you put the S here, you better go clockwise or counterclockwise with STAR. You cannot go S and then diagonally T. So if you're drawing your own picture, be careful, make sure you set it up correctly. All right, so on this particular one, you have the height here, so they may not label this as height, but anytime you see a perpendicular line to any of these bases, you need to understand that that's the height. And so all you've been given is that RA is 20, and that this is a 45-degree angle here, and this is 9. And you have to find the area. Do I have the base and the height of my parallelogram? No. But what I do have, and you have to be comfortable with the fact that I drew this specifically this way. If this is 45 degrees, what is this supposed to be? 45. Is this really a 45-45 triangle that I've drawn? No. Visually, it's not. I mean, this leg is not the same as this leg. Your textbook will do that to you all the time so that your eyes war with what your brain is telling you it should be there. So you need to try to get over that. Don't get out your protractor. Don't get out your ruler and try to measure things. They're not going to measure up. If this says 45 degrees and you get out your protractor and like, well, it's not 45, that's right, it might not be. Don't let that bother you. So put your protractor and your ruler away. If I want to find my height, which is here, can't I use just this right triangle to find my height? Since it's a 45-45, can't I use my knowledge of the pattern for 45-45 and find what's across from this 45-degree angle? So I'm going to go ahead and put over here I've got 45, 45, 90, and then I'm going to put my pattern of 1, 1, red 2, and then I'm going to make my proportions. So I only know one thing really, and this 9 is across from my right angle. So the 9 goes underneath the rad 2, and then I'm trying to find h, which is across from 45, so I'm going to put an h underneath my 45. What's wrong? Okay, so write this down, because we're using prior knowledge. So I'm going to solve that proportion. So h times rad 2 is h rad 2 equals 9. How are you going to solve? Divide by radical 2. Can I leave my answer like this? No. So I have to rationalize, right? So whatever your denominator is, multiply top and bottom by that rad 2. And so h is really 9 radical 2 all over 2. So it's not a happy height. But now, so this is step 1. So step 2, I can now use my formula, my area formula. If I don't see the following, because you have to get in this habit, so I'm going to be mean about it. If I don't see you writing A equals B times H, do not skip the general formula. Because the general formula is going to help you in situations that are harder and help you, and you've got to use your algebra. So if you're not setting up equation, you're just doing scratch work, there are a lot of problems that you're going to get lost in because you're not used to starting with that formula and plugging in for what you know. And so here I now know that my base, there's my height, this is my base. So I'm going to plug in 20 for B and 9 rad 2 over 2 for my H. And here's my 20. I'm going to put 20 over 1 because I know that my height over here is a fraction. Can I cancel anything? The 2 cancels in the 20, 10 times. And so my area is 10 times 9 because I can only multiply what's outside of a radical to what's outside and what's inside to what's inside. So I get 90 radical 2. And I don't know what the units of measure are. The other thing I want you to get in the habit of, and I'm bad about it, so you have to remind me, isn't this 20 units and isn't this 9 rad 2 over 2 units? So I don't know if it's inches or feet or fuzzy nagels. I have no idea what the unit of measure is, right? And so what's units times units? If you get in the habit of putting your units in the formula as you solve it, you won't have to remember, well, is area squared or is it cubed or is it just to the first power? Because a lot of you still struggle with that. You won't have to struggle if you put it into your formula. I don't want you to break out the calculator and get the decimal. Now your textbook might say round to the nearest tenth. If that's the case, I want you to come up with this answer and then you can break out your calculator and write the decimal somewhere off below it and then compare it to the answers that are online. Because on your test, you most likely will leave them in exact form. This is the exact area. If we use a calculator, we're going to end up estimating. And there are times when estimates are good and times when they're not so great. So you need to know how to estimate. All right, example 2. Then you're going to have some figures in this section that aren't your normal shapes. So again, you're going to find the area. And this time, By the way, if you don't have graph paper at this point, you absolutely positively must have graph paper. So go out and get some. You're past overdue having it. So we have this L-shaped figure. This side is 18. This side is 6. This is also 18. And this is also 6. Is that a polygon? Is it closed with straight sides? Yes, so it's a polygon. It's not one that we normally name. So you have to decide, you have to cut it into pieces. You have to cut it into shapes that you're familiar with, squares, rectangles, triangles. I can cut this two different ways. Can't I cut it this way, into a long and a short rectangle, or this way, into two equally sized rectangles? Bless you. You cut it however you want to. I'm going to cut it there because I know that this length is 18 and this width is 6. And I know on this rectangle, this length is 18 and this width is 6. So how am I going to find the area of it? How do I find the area? What shape is that? A rectangle. What's the area form of a rectangle? Same thing for that one. Then once you find the area of these, what do you do with them? Add them together. So I'm going to name this shape 1 and this shape 2. Bless you again. And so for shape 1, we have area equals length times width. Plug in my length and my width. I've got 18 units and 6 units. So then if you can't do 18 times 6 in your head, then do the scratch work off to the side. 6 times 8 is 48. 6 times 1 is 6 plus 4 is 10 units squared is the area for, and I'm going to put a little sub 1 here, area for shape 1. And then can't I say for number 2 that the area of shape 2 is also 108 units squared because I recognize that they're the same. And then I can go ahead and add them together and I get 216 units squared for area 1 plus 2. Done. Now if they're two different shapes, you're going to have two different sets of work. Now, the last thing I want to discuss with you before I give you some problems on a study guide is let's talk about conversions. So what if I had the following? Make a square. We've talked a little about this when we were doing our Ames reviews. Bless you. This is 1 foot, and this is 1 foot. Isn't this 1 square foot? When I do length times width, I have 1 square foot. How do I convert that into squared inches? So I want the same size. So 1 squared foot is not 12 squared inches, right? And so we've got, if 1 foot equals 12 inches, then I'm going to let this side be 12 inches because I'm replacing 1 foot with 12 inches, and this side is also going to be 12 inches. So that means that 1 foot squared is equal to how many squared inches? What's length times width? Yep, 12 times 12 is 144. So the area here is 144 square inches. And so 1 foot is equal to 144 square inches. So if you have different units of measure and you have to use a conversion, bear in mind that if you have to convert something that's in squared units, you might want to write yourself a little picture and figure it out. So if I went to yards, 1 foot would be what, if I did this in yards, 1 foot would be how much of a yard? 1/3 of a yard. And so that would be 1/3 of a yard. So 1 foot is equal to how many squared yards? What's 1/3 times 1/3? 1/9 squared yards. So it's a 5. All right, so let's look at some problems off of your study guide. Oh, the wrong one. Don't you love it? Passing forward. It'd be really nice if I could grab the right pile, huh? That was just an exercise, and then you pass paper back. Will you all pass them towards Hunter on that side? How about that? That's better. All right, so on here we've got, again, the one formula that you're going to be working with is highlighted for you. These ones here are pretty simple to find, aren't they? 1 and 2. What are you going to do with 1 and 2? What are you going to do? Base times height, right? And here, same thing, base times height, so I'm not even going to go over those. Those are easy. Let's look at number 4. So you're just to find the area of the shaded region. So when you're doing these, can't we take the area of the whole entire rectangle and then pretend like it's a cake and somebody doesn't like all the frosting that's on the side pieces of the cake? They want a piece of cake out of the center. So they've gone and they've cut a cake out of the center and they've just removed it. Won't there be like that frame left there? How rude of them. So for these problems, I suggest you take the area of the big and you subtract the area of the small. And as you can see on number 6, wouldn't you subtract 2 things here? So that one's a little bit more complicated. So the outside is a rectangle and the inside's a rectangle. So I've got length times width minus length times width, because those are your area formulas for each of those. And then I'm just going to plug in. So my big, I've got 48 and 22, and I've got 48 meters and 22 meters. And then for my small, I have 12 meters and 7 meters. So off to the side, you're going to calculate what is 48 times 22. And so we get 1056. 1056 meters squared minus, what's 7 times 12? What is it? 72, 64, none of which are correct. What's 7 times 2? There you go, we got 84. 84 meters squared. And so then I'm going to take my scratch scratch work up here and I'm going to subtract 84. So I get 2, 7, 972 meters squared is my area. And then we're going to do 7 and 8. So 7 and 8, have they drawn the pictures for you? Nope. So 7 says the area of a parallelogram is 24.96 centimeters. The base is 6.4. If the measures of the base and the height are each doubled, find the area of the resulting parallelogram. So I start off with knowing what the base is. Do I know what the height is of my parallelogram? But what do they give me to help me find the height? I've got the area, right? So I can use the area formula and the base, and I can find my height of my original parallelogram, and then can't I double my lengths and then find the new area? So I'm going to give you a gift. What kind of numbers are here? And what does your textbook think you're always using? Okay. So I will allow you to use a calculator if and only if you do what? You got to show your work. So you have to tell me what you're plugging in. So I'm going to do the work on the back here so I have more work to move, but I'm going to draw this picture and I'm going to keep flipping back and forth so I can, well, I won't flip because I've got an extra one. Yep. All right, so we're going to draw our 4-step plan. So I'm going to draw a parallelogram. And they tell me that the base is 6.4 centimeters. And then the area is equal to 24.96 centimeters squared. The problem is that I don't know the height of that parallelogram. So my very first step out here is to find the height. So your work goes down here. So those 2 boxes are purely for your work. So I'm going to use the area equals base times height formula. I'm going to plug what I know into that formula. I know my area is 24.96 centimeters squared equals, I know that my base is 6.4 centimeters, but I don't know my height. So how are you going to solve? And I need to see that. Your calculator is a tool. It does not do the work for you. It just helps you with it. You still have to show me what you're doing. So as if you're not using a calculator, you have to show me what you're doing. And so now you can break out your handy dandy calculator and calculate 24.96 divided by 6.4. And so I get 3.9. 3.9 what? Yeah, because this centimeter cancels with one of those, and so I get 3.9 centimeters. So in my picture, I'm going to put 3.9 centimeters. So then it goes on to say, if the measures of the base and height were each doubled, find the area of the resulting parallelogram. So my new, so base sub 2 is equal to double 6.4, what do you get?
4.8.
And that's just centimeters, right? And my new height is going to equal what? Double 3.9, what do you get? What'd you get? 7.8, and that's also centimeters. What do you expect is going to happen to your area if I double mine? What do you propose? What's going to happen to area? Is it going to double, quadruple? What do you think? Doubled? Okay, well, let's see. So my area sub 2 is equal to base sub 2 times height sub 2. My second base and height. So plug in. I've got 12.8 centimeters and 7.8 centimeters. And I get 99.84, and it's centimeters squared. Let's just divide these and see what happens. So I'm going to take my 99.84 and divide it by 24.96. What'd I get? 4. Why is it quadrupled and not doubled? We doubled the dimensions, but our area quadrupled. Remember the area is squared, right? So if I double my measurements and area squared, what's 2 to the second power? 4. What if I tripled my measurements? What would happen between these two? What's 3 to the second power? So it would be now 9 times as big. What if I quadrupled my measurements? What's going to happen now? What's 4 to the second? 16 times as big. So that's what's happening. Your units are squared. So if it were volume and I doubled my measurements, what would happen to the volume from the original to the new? If I doubled my measurements. Volume is what? Cubed. So what's 2 cubed? 8. So you'd have 8 times the volume. So now that we're working in a different dimension, now if I were just doing perimeter only and I doubled my measurements, then the line of the room would just double. But the area would quadruple. Okay, so therefore, the area of the resulting parallelogram is 99.84 centimeters squared. Okay, and then let's look at the last one here, number 8. So this time you have a rectangle is 6 meters longer than it is wide. The area of the rectangle is 315 square meters. Find the length. Okay, so let's draw a picture. And I've run out of lead, or black pen, yay. Alright, so we're going to draw a rectangle. Which do I know nothing about? It told me that a rectangle is 6 meters longer than it is wide. What do I know nothing about? The width, because aren't they describing the length to me? So if I don't know the width, I'm going to let the width be x, or in this case, I'm going to let it be w. And then if the length is 6 meters longer than it's wide, what's the length? W plus 6. And then they go on to tell me that the area is equal to 315 square meters. We're finding the length. So what do? What's your first step? The minute they give you area, what's your first step? Write your area formula down. If they gave you perimeter, you'd write the perimeter formula down. If they gave you volume, you'd write the volume formula down. And this is a key to tell you how to start the problem. So I'm going to start with my area formula for a rectangle. And I'm going to plug into that formula what they give me and solve for what I don't know. So they have given me 315 meters squared equals my length is W plus 6. And by the way, that's in meters. It's kind of a pain when you have variables over here to put meters in here. So I am going to drop that off. And then my width is just W, isn't it? We have to distribute the W into the parentheses, so I get 315 is equal to W squared plus 6W. Oh, what does that imply? What are we going to have to do? Factor. So what do I have to do in order to factor first? Subtract 315 from both sides. You always want your squared term positive. So, and then write in descending order, W squared plus 6W minus 315. So let's go ahead and factor. I'm going to multiply my bookends together, so it's 1 times negative 315. I get a product of negative 315. Because it's negative, I'm subtracting my factors of 315. I'm looking for my middle term of 6. So if you don't know off the top of your head, because you're not really familiar with 315, just start 1 and 315 and just go meticulously through your factors. Does 2 go into 315? No. How about 3? What's 3 plus 1 plus 5? 9. So both 3 and 9 divide into there. So 3 goes into 3 once. It goes into 1 0 times. And it goes into 15 5 times. If I subtract those, I get 102. Still much closer than before. Does 4 go into 15? So 4 doesn't go into 315. Does 5 go in there? Yep. So 5 goes into 31 6 times with 1 left over. 5 goes into 15 3 times. And so now I have 58. So we're getting much closer. How about 6? Does 6 go in there? Nope. How about 7? Well, you have to test it. 7 goes into 31 how many times? 4, and that's 28. How much would be left over? It goes in there, doesn't it? 7 goes into 31 4 times, and so it's got 3 left over. 7 goes into 35 5 times. What's 45 minus 7? 38. What about 8? Well, 4 didn't go in there. Is 8 going to go in there? No. 9. We already tested it, right? So 9 goes into 30 how many times? 3 times. So that's 27. How many's left over? 4. So 4 goes in front of the 5. So 9 goes into 45 how many times? 5 times. What is 35 minus 9? 26. Yep. So we're better. How about 10? No. 11? Well, here's a clue for 11. What's 3 plus 5? 8. Is that the middle number? Nope. So 11 doesn't go there. How about 12? Well, 4 didn't go in there, so 12's not going to go in there. How about 15? Why would I say 15? I'm going to just jump a little bit. 3 and 5 went in there. Let's just try 15. 15 goes into 31 how many times? Twice with 1 left over. And 15 goes into 15 once. What's 21 minus 15? Oop, there it is. So with a little bit of persistence, you can find it. Cole, you won't be that persistent, will you?
That's just a lot.
It is a lot, so you have to be persistent, right? Now, you are going to have use of a calculator, right? So can't you help your calculator can help you come up with those factors, right? All right, so our 16 is positive. The bigger of the two gets the sign. What's the 15 going to be? Negative. Now the good news is, because there's only a coefficient of 1 here, this is our shortcut factoring. We don't have to do group and garbage. W squared becomes W and W, and then you can put minus 15 here and plus 21. So if I set each of those equal to 0, what are my choices for W? 15 and negative 21. Well, which one is not going to be possible? Yeah. So that means my width is 15. So go back to your let statement. Your width is 15 and it's meters, right? What's your length going to be? What's 15 plus 6? So my length is 21 meters. And by this time I forget what the question is. So the question says find the length. Did we find the length? Yes. So therefore, the length of the rectangle is 21 meters. So they're not all going to be super easy problems. You are going to have to use prior knowledge from both algebra and geometry to solve some of these.